welcome to Two Projects. In this video, we are going to discuss about the project which is detection of imbalanced network traffic based on machine learning and deep learning. So before getting into the execution, let me give you an overview of the project. So imagine internet as a busy city with the data moving around like cars on streets. Sometimes malicious data, which is called as cyber attacks, they hide among regular data and which is very hard to detect. This is especially tricky when some types of data they dominate the scene and create an imbalance in the network traffic. So what is the impact of malicious data is they disrupt the services, they steal sensitive information and they even cause forms of damage, that is other forms of damage. By effectively detecting and mitigating these threats, we can safeguard the network integrity and we can also protect against potential harm to the users as well as organizations. So traditionally, rule-based methods they were used for managing this network traffic. While they work well in predictable situations, they even struggle with handling unexpected events or changes in traffic patterns, wherein these days there are unexpected situations. So, what are we going to do in this project? We are going to develop an efficient system that will accurately detect and classify this network traffic and resolve the limitations of this traditional rule-based methods. So the author in the base paper, he has proposed a technique called difficult set sampling, which is DSTTE. It's a novel method proposed by the author for addressing class imbalance in intrusion detection datasets. It divides the training set into difficult and easy subsets using the method called edited nearest neighbor algorithm. So then it compresses majority samples and synthesizes new minority samples by enhancing classifiers' ability to discern intrusions. And this DSSTE algorithm is individually built on various machine learning and deep learning algorithms. So this DSSTE algorithm is individually built. It is combined with these algorithms and it will predict the traffic, that is network traffic. And all these models are built on NSL-KD dataset as well as CSC CIC IDS 2018. So moving on, as an extension, we are employing voting classifier to further improve the performance. So what this voting classifier is, it is an ensemble method. It will combine predictions from decision trees and random forests. So here in the project, we have combined decision tree and random forest in the voting classifier. It blends the output and it's aimed for a stronger, that means it is aiming for stronger and more accurate final prediction in intrusion detection. This approach leverages the strengths of different models, potentially offsetting individual weakness and ultimately enhances overall performance. So, moving on, how did we implement this project? So, first, we explored the data set to understand the problem. So, the data sets are CIC IDS 2018 and NSL KDD. We have explored both of these data sets. And then we cleaned up the data and then used DSSTE to fix imbalances. And then we extracted important features from the data and we trained multiple machine learning and deep learning models along with the voting classifier model. And then we have evaluated all these models using accuracy, precision, recall, and FN score, and then selected the best performing algorithm. After training and testing, we see which model performs best at detecting intrusions in imbalanced network traffic. So our proposed model voting classifier has performed well and we have selected it. And this model becomes our go-to tool for ensuring network security and efficiency. So moving on to implement this project, we need software and hardware requirements. So coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And hardware requirements which are needed are Windows operating system, i5 and above processor, 8 GB and above RAM, hard disk of 25 GB and above. So these are the algorithms which are built in the project. We build algorithms which are in the base paper as well as we also built our proposed model voting classifier to see how well the voting classifier is performing than the other algorithms which are proposed in the base paper. So As voting classifier has performed well, we have deployed it in the front end and detected the network traffic. Let's understand what is this voting classifier. Voting classifier, it is an ensemble technique and it combines predictions from various models. So here, decision tree and random forest are combined in the voting classifier to assess the likelihood of an attack occurring within the traffic, that is network traffic. Each model, random forest, and decision tree, they independently analyze different categories of the traffic data, such as packet headers and traffic patterns, to determine if an attack is presented. So this voting classifier, it aggregates these individual predictions using methods like majority voting or weighted averaging to enhance the accuracy and reliability of attack detection in the network traffic. So as of now, we understood what is this voting classifier. Now let's execute the project. To execute it, first we have to open the code folder, which has source code files in it. So these are the source code files in the code folder of the project. So let's understand each file, how will they be used in the project. So first we will see this data folder in which we have dataset. So here in this folder we have NSL KDD dataset, that is raw dataset, and here we have CICIDS 2018 raw dataset. So first let's see this CICIDS 2018 dataset. So this is the dataset of CICIDS 2018, and these are all the parameters in it. So here we have this dataset. We'll be pre-processing this dataset and then we will remove the class imbalance in it and store it in another Excel file. So this is the pre-processed CIC IDS 2018 dataset. So here is the pre-processed CIC IDS dataset, and here class imbalance is also removed. So these are the parameters which are important for predicting the network traffic, detecting the network traffic. So we'll be using all these parameters to detect network traffic. And here in the last column, we have different types of network traffics. So now close this. We'll be training this data to detect the network traffic. So now close this. And here in NSL KDD folder, we have raw data of NSL KDD. Here in this folder file, we have NSL KDD dataset. So this is the raw NSL KDD dataset. We'll be pre-processing and we'll be removing the class imbalance from this. So now close this, get back. After pre-processing and removing the class imbalance, here is the dataset. So this is the pre-processed dataset of NSL KDD. We'll be using this dataset to train all the algorithms. So here in the last column, we have the target label. Now close this, get back. Here we have sample CIC IDS 2018 and sample KDD. So in which we have the test cases to detect the network traffic in the front end. So I'm opening it. So these are the test cases. It's the first test case. This is second test case. Similarly, we have some more test cases. So we'll be using these to detect network traffic in the front end. So now close this. Here we have test cases of NSL KDD dataset. So these are the test cases for detecting the network traffic for NSL KDD dataset. So these are the parameters, and here we have the target label. So now close this. Moving on to the static folder. This folder contains files related to the project styling and interactivity. They are CSS, JavaScript, and Bootstrap files. And here we have templates folder. Here we have HTML pages utilized in the project. They are index.html, about.html, etc. Each HTML file represents a different page of the website and provides structure and the layout for displaying content to the users. And here we have app.py file. This is a Python file which encompasses front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. So these two are the model files which contain the algorithm information, and they will be loaded into the project code during runtime. And these two are the IPYNB files. These are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. So here, this is CICIDS 2018 IPYNB file in which we have code related to CICIDS dataset. Similarly, in this NSLKDD IPYNB file, we have code related to NSLKDD dataset. Here in this last file, which is signup.db file, this file is a database file which is used to store the user information. Now we will copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port, unless configured differently. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome. Paste the link here, then click on enter. So this is the web page of the project, which is displayed in the browser. And this web page is built using Flash framework. So first we have to sign up. So click on sign up and enter all the registration details if we are registering newly. I have already registered and have an account in it. So I will directly sign in. So click on sign in and provide username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. So we are going to do prediction for both the datasets that are NSLKDD and CICIDS 2018. So what is difference between these two datasets? NSLKDD is originated from KDD Cup 1999 dataset and it is smaller and it contains predefined attack types. While CICIDS 2018, it is developed by Canadian Institute of Cybersecurity and it is larger, more diverse, and it captures real-world network traffic from multiple sources. So first we'll do prediction from NSLKDD dataset. So click on NSLKDD link. Here we can see the parameters which are need to be entered. Based on the entered parameters, we will get the prediction whether it is of which type of attack. So let's understand all the parameters. The first parameter we have is SRC bytes, which is nothing but source bytes. It is the number of bytes sent by the sender in a network communication. Moving on to the destination bytes, it is the number of bytes received by the destination, that is receiver, in a network communication. The next one is logged in. Logged in is nothing but it indicates whether a user is logged into the system or not. The next one is count. Count is the number of times a particular event or activity occurs. The next one is error rate. Error rate is the rate of connection that attempts that resulted in SYN error. Error rate is source error rate. Next one is SRV error rate, which is service source error rate. It is the rate of the connection attempts to a specific type that resulted in SYN error. The next one is same SRV rate. It is the same service rate, the rate of connections to the same service among all the connections observed. Here we have different SRV rate. Different SRV rate is nothing but it is the rate of the connections to the different services among all connections observed. The next one we have is destination host SRV rate. It is the destination host service count. It is the number of connections to a specific service initiated by the destination host. The next one is destination host same SRV rate, which means that it is the rate of connections to the same service initiated by the destination host. The next one is destination host different SRV rate. It is the rate of the connections to different services initiated by the destination host. The next one we have is destination host error rate. So this is the destination host. Error rate. It is the rate of connections attempts to the destination host that resulted in an SYN error. The last one we have is destination host SRV error rate. It is the host service source error rate. The rate of connection attempts to a specific type initiated by the destination host that resulted in an SYN error. So we have understood all the parameters. Now let's enter them. We have test cases in sample file, so we will open it first. As we're doing prediction for NSL KDD, open the sample KDD file. So now we will enter these parameters. So we'll use the first test case to predict the network traffic. So let's enter the parameters. So the source bytes are 223. Moving on to the destination bytes, they are 21,000. They are 21,786. Logged in value is 1. Count is 3. Error rate is 0. SRV error rate is 0. Same SRV rate is 1. Different SRV rate is 0. Destination host SRV count is 255. Destination host same SRV rate is 1. Moving on to destination host, different SRV rate is 0. So all the next parameters are 0. So I'm entering them. Now click on predict. So based on the given parameters, here we got the prediction as there is no attack detected and it is normal. So let us enter other set of parameters, that is the other test case. So we'll be detecting for the same data set. So click on prediction. Under prediction, click on NSL KDD dataset. So we'll be using the fifth test case. So I'm using the fifth test case. So here SRC bytes are 0. Destination bytes are, sorry, SRC bytes are 42. Destination bytes are 75. Logged in value is 0. Count is 152. Error rate is 0. SRV error rate is 0. Same SRV rate is 1. Different SRV rate is 0. Destination host SRV count is 225. The next one, which is destination host, same SRV rate is 0.88. Moving on to destination host, different SRV rate is 0.01. The next one is destination host error rate. It is 0. The last one, which is destination host SRV error rate is 0. So we have entered all the parameters. Now click on predict. Here, based on the given input, we got the prediction as there is attack detected and the attack type is R12. In this, we will enter some more set of test cases. So click on NSL KDD. I entered all the parameters. Now click on predict. So here we got the prediction as there is an attack detected and the attack type is probe. Here attack is classified as probe, which is probe attack. So let's enter some more test cases for the same data set. I entered all the parameters. Now click on predict. So here we got the prediction as there is an attack detected and the attack type is U2R, which means the attack is U2R. So let us enter one more test case for the same data set. I entered all the parameters. Now click on predict. So based on the given parameters, here we got the prediction as attack type is DDoS and DDoS is detected. As of now, we have completed prediction for NSL KDD dataset. Let's do the prediction for CIC IDS 2018 dataset. So click on CIC IDS 2018 link. So here we can see the parameters in CIC IDS dataset. So we need to enter all these parameters to get the prediction. So before entering, let's understand them. So here the first parameter which we have is flow duration. It is the length of time of flow, that is a sequence of packets with same source and destination IP addresses, transport protocol and port numbers exist. Moving on, the next one is total length forward packets. It is the total length of forward packets in a flow. The next one we have is total length of backward packets in a flow. Moving on to the next one, it is forward inter-arrival time total. That is the total time between each forward packet in a flow. The next one is backward header length. It is the total length of headers in backward packets in a flow. The next one we have is max packet length. It is the maximum length of packets in a flow. Moving on to average packet size. Average packet size is the average size of packets in a flow. The next one we have is average forward segment size. It is the average size of forwarded segments in a flow. The next one we have is average backward segment size. So it is the average size of backward segments in a flow. The next one we have is subflow forward bytes. It is the number of bytes in the forward direction within a subflow. The next one we have is subflow backward bytes. It is the number of bytes in the backward direction within a subflow. The next one we have is initial window bytes forward. It is the number of bytes in the initial window in the forward direction. The next one we have is initial window bytes backward. These are the number of bytes in the initial window in backward directions. So we have understood all of them. Let's enter them individually. So now let us enter these values using the test cases, and those test cases are in sample file. So I'm opening this sample CIC IDS 2018 file. So these are the test cases. First, we'll use the first test case. So we'll be using this test case. So let's enter the values. The first one is flow duration. Copy this, paste it here. The next one we have is total length of forwarded packets. It is 1735. The next one we have is total length of backward packets. The next one we have is forward packets, forward IAT total. So I'm copying it. The next one we have is backward header length, max packet length, average packet size, average forward segment size, average backward segment size, subflow forward bytes, subflow backward bytes, initial window bytes forward, initial window bytes backward. So we entered all the parameters. Now click on predict. So here we got the prediction as there is an attack detected and the attack type is benign. So the attack is benign. Let's enter some more test cases. So we'll do the prediction for the same data set. Now we'll use other test case. So we'll be using the test case number 5. So here the flow duration value is this. I'm copying it here, pasting here. The next one is total length of forward packets. Similarly, I'll enter all the parameters. Moving on, next one we have is forward IIT total. backward header length, maximum packet length, average packet size, average forward segment size, average backward segment size, subflow forward bytes, subflow backward guides, initial window bytes forward, initial bytes backward. So the last one we have is initial bytes backward. So they are 229. So now click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. Similarly, we'll enter some more test cases and get the prediction of network attacks. I have entered all the parameters. Now click on predict. So based on the inputs provided, here we got the prediction as there is an attack detected and the attack type is bot. So we will enter some more test cases. So I entered all the parameters. Now click on predict. Here we got the prediction as attack type is DOS Hulk. So the attack is DOS Hulk predicted. So we'll enter some more test cases. So here I entered all the parameters. Now click on predict. So here we got the prediction as there is an attack detected and the attack type is DOS GoldenEye. So this DOS GoldenEye is predicted. Now we will enter one more test case, the last test case. I have entered all the parameters. Now click on predict. So here we got the prediction as the attack type is DOS sloth test. So it is sloth test. As of now, we have completed the prediction for both the data sets. In just this way, we will enter the parameters. Based on the given parameters, we will get the prediction of detected attack type. Now we will see the graphs of the project. So click on graph.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.